just keep going. All right. So any questions before we start on our quest into mapping? Okay, if not, then we can go ahead and open up Xcode. RCV, we'll create a new one. Just a simple single view, really not simple, but a single view. Let's see, what can we call this? Where are we? Swift phone, okay, great. And create, and we're off and running. Boom. All right. So what we need to do, first things first, before we do anything else, we have to let it finish indexing. So anytime you switch, you probably notice that anytime you switch simulators or switch to a device or switch devices, it'll do that. It'll index the files. It has actually different debug symbol files that it loads based on the device that you select. So if you ever see that, it says indexing, processing, that's what it's doing. All right. So let's see here. First things first. When we create a project currently, we always get the, it always automatically creates this boilerplate code for us, and it does this import of the UI kit. The UI kit gives us many wonderful and fantastic things. One thing it doesn't provide, though, is mapping functionality. So to get that, we have to add that in specially. If you go up to your project level, your highest level in the folder structure, and then go into the Build Phases tab, and here you have some fascinating things. One of them, first of all, I think we kind of touched on this briefly before. You have the compile sources. These are the files that get compiled into your binary. And then we have this linked binary with libraries, which basically is other binaries or libraries that you're linking into the project. Now in here, we need to add something in. So on the if you expand this on the little, click on the plus sign, a list of frameworks drops down. So these are all frameworks that are available through Xcode for iOS. We want to add in the MapKit framework. It's all alphabetized. Some of these are actually like CDLLs and Objective-C DLLs and that kind of wonderful stuff. But we get down here, this is actually a framework file, mapkit.framework. Select that and click Add, and that will add that framework into the project and allow us to use maps. You can create a project with a map view in it without selecting this. It'll let you do that. It'll let you add the map kit into your storyboard, and then when you go to run it, it'll crash hard. And then you know you did something wrong. However, it doesn't tell you that that's the problem. So if you ever experience that, that likely is the problem. that was not included, that framework. So it's another little Apple gotcha. Got to have that MapKit framework included in order to use maps. So if we go into our view controller, then we also need to add an import statement. Oh, map, not map. MapKit. So the linking in the binary allows us to access the actual source code. Importing it makes the various interface methods available to us, kind of like with a delegate and a protocol. All right, then the next thing we want to do, now that we have all that stuff all ready to go, is I'm going to go into my view controller in the storyboard. And I'm going to set this to like a 4-inch or so. It should be pretty good. And you can move these guys around at will if you want. We need to add a map view. So down here in our library, one of these guys should exist. There it is, map kit view. If you select that, is an MK map view. So this gives you a kind of a visual cue right off the bat that this is not part of the UI kit because it starts with an MK, which of course stands for map kit. So you can drag and drop that on. Kind of position it to suit your needs. We'll take up pretty much all the space available. Do our usual trick with control drag to center it. And also I think I'm going to set a constraint to the top and bottom so that we take up most of the available space. And if I could do this, all right, vertical spacing to top layout guide. I'm going to set that to be about 30 or so. And then the same thing with the bottom. Having real trouble with that tonight. There we go. Bottom layout guide. And I'm going to set that to be about maybe like 20. There. So now we have a map view added into our main view controller. Next thing we want to do is create an outlet for this guy. So I'm going to rely on my handy-dandy assistant here. There we go. Life is good. It brought it up. Now I got the spinning wheel of death. So if you all are able to do that, you can go ahead and do a control drag and create an outlet for it. Just call it map view. I will do likewise once I have the ability. All right, here we go. Boom, we got a map view. Okay, so if we go ahead and run this right off the bat, this should load up our map for us somewhere in the world. I'm not sure exactly where it's going to, because we're in the simulator, we don't have geolocation, so we'll see where it puts us. Looks like we had some time here, so everyone following along okay so far? Everything looking good? Okay. I'm actually kind of surprised it's not busier tonight with all the voting and all the other stuff that's going on. Like I live in Plover, and the Plover Municipal Center is like cars all over everywhere.
I waited over an hour just to get in.
Yeah, I went this morning right off the bat, and I got there like 8 after 7, and it's opened at 7, and the line was already all the way through the building and outside.
Guess that's one benefit of living in a small town. No lines for voting.
I kind of thought Plover was a small town, but
I
apparently
should say small village.
yeah. And something's happening. I'll see what happens there. And there we are, somewhere in the world. So that loads us up a map. We don't have any geolocation, like you say, so it doesn't center it anywhere for us. So that's going to be our job to do, is to create a location and center it on that location. So next thing we will do is create some variables here in our view controller. First of all, if everyone get theirs to load, okay. It will not load if the internet is not on. It just flat out won't do it. You get a grid, an empty grid, without an internet connection. Okay, so next thing we need to do, we're going to create some, before I do that, so let's figure out where we are. Stevens Point, okay. There you go, coordinates, 44 degrees, 31 minutes, 23 seconds. So that is our location. So what we can do is come into this guy, and we'll create some constants. We'll set the latitude equals 44, 60 minutes to 1 degree, 60 seconds to a minute. So it's 31 minutes, so it's about roughly 5.5. So this is just the decimal equivalent of this. 0.5 and about 3. 0.453, call it 4530. That's our latitude. And our longitude, I just happen to know that this is negative. Yeah, otherwise you end up somewhere really weird. Negative 89 point, about 5, 1, make that like 5, 4. End up 5, 5, 0, 4, 0. That seems pretty reasonable. All right. So that's our latitude and longitude. Another thing I'm going to do right off the bat is create an array of stores. This needs to be a var. Sorry, we're gonna mutate this var stores. This will be an array of NS dictionaries. Beautiful. All right. Now we have this all fine and dandy. We need to create a method. So with a map kit, it basically, you set what's called a region, a map region, and the region defines the size, the radius that you're looking at, and the center location. So we're going to create a method that will allow us to tell the map kit where to center the map to focus on and what our region size is. And then we'll see how close I am with my estimation there. All right. Call this center map on location. And then we'll pass in a location object. This is a CLL location. Because this will change. Bless you. So ECL, prefix to this guy, not MK. CL is core location. So if we had this running on an actual device, we would use a CL location manager. We would receive updates to our location, and we could reflect those updates on the map. We don't have a physical device, or at least I don't have a physical device connected right now. We're using a simulator. So we're not going to be updating the core location, but we can do it manually. We can actually tell it where to go, and then that creates location objects when we do that. So what we can do is say let initial location, and we'll go ahead and construct this guy. Location, just like that. And then this takes 2 parameters. Latitude and longitude, and the latitude is going to be lat, and longitude is going to be lon. Oops, lon. And then we call, we're going to call another method, which is going to be mapView dot set region. Oops, region. And the region is going to be a coordinate region that we need to create. Let's do this. We need to create the region first. So let's create a region. Coordinate region can be created from a coordinate. So let's do this. Say let region equal, and this is a MK. So most of the stuff that works directly with maps is an MK, map kit. The other stuff is core location. All right. And I'm going to change this too. This was tomfoolery. We need to pass in, we need to use the variable we passed in. Dot latitude. Altitude? Well, no, latitude. This is not working the way I wanted. Okay, so we got CLL location passed in. Oh, I'm sorry. Here, I know I did wrong. Location.coordinate. There we go. All right. And then dot latitude. Okay, so the location that's passed in has a coordinate, which is a CLL coordinate 2D, I believe, and then that has a latitude and longitude. So we need the coordinate, the location.coordinate latitude, coordinate.location longitude. There. That looks better. Then we have our region. So the region is going to take the center point. The center point is going to be this guy. And then the coordinate span is in meters, basically. So we can set for a radius. Let's try 2,000. Just try that, just for the fun of it. Now down here with the set region, we can set our region and animated true, because we love animations. And there's still something it doesn't like up here. This guy needs to be a dot coordinate. There. Nope, still not right. Not saying something about my inth. Okay. So this needs to be a CLL location distance. Interesting things going on here tonight. All right. CL location distance. Let's see if it likes that. No. All right. So let's do this. Let's say let location distance equal 2,000. Here. Well, let's do this. We'll do it this way. CL location distance. There. Then we can call this passing in location distance. And it still doesn't like it. All right, now what? Okay, regions, region, center is initial location at coordinate, span. Let's do this. Nope. All right, so it's not liking this. I'm gonna start over with this region guy. Coordinate region. I think I know what's wrong. I passed in a single. All right, I think I know what's wrong. All right, so for the location coordinate 2D, we can use location, or initial location, sorry. Initial location dot coordinate. Sorry to make you type all this. For the span, I think we can use MK coordinate span. And all right, so for the span, we need the delta, which is going to be location, distance, I think, and location, distance again. Yeah, obviously I've changed this stuff since the last time I used it. Oh, I don't like that. That's not right. All right. Wow. Okay, so there it is, finally. We had to create a CLL location off of the passed-in location. Then we create a MK coordinate region off that. The region centers it, creates a span using the span, which is a little different than what it used to be. It used to be you could just use a couple of double values and it was good. So there's a few things that have changed, but I think we're good to go. So we'll go ahead and run this. And hopefully that will center it and do something I expect it to do. It would, but will not do anything unless I call it. So in our view did load, let's call that guy. And we'll use a CLL location object using the lat and long. All right, now what? All right. Now, let's see if it works. Oh, spinning wheel of death and signal abort. Okay. Invalid region. Okay, so has everyone else got this too? Okay, perfect. All right. Thing it does not like about our region, so do a stop. And go back in here and see what it doesn't like. Let's see, coordinates, span, MK coordinate span, latitude delta, longitude delta. All right, this guy looks fine. All right, let's go ahead and debug it. See what happens. Okay, so it's got a location. That all looks fine. Created the region. latitude, longitude, okay, span. Oops. Latitude, delta, longitude, delta. All right. And it does not like that region. So, let's see why we don't like the region. You know why I think it doesn't like the region? Because I called a region without, all right. There's a couple of different ways to make these guys. I'm going to delete this code. And I'm going to call MK coordinate region if I could type coordinate region make region coordinate region make with distance. Whew. All right. And now this guy, I think we can do basically what we were doing before. So this is the one that takes, okay, this is the one I was thinking of that takes just a value in meters. All right, so initial location, and then for this we will pass in 2000 and 2000. See what it doesn't like about this. Can I convert that to something? To extract your element type CL location coordinate 2D.
Dot coordinate.
Yeah, thank you. Exactly. Good catch. All right. Try it again. See what happens. Continue. All right. A little bit painful, but there we are. So that centered in our radius of 2,000 meters in Stevens Point. Pretty close, Park Ridge area. All right. So after all that, the mistake I made originally was I had this MK coordinate region without the make with distance, which is what I was actually looking for. That's where all my confusion resulted from, was I wasn't using the correct constructor. So now that we have that figured out, is everyone else able to load the map okay? Yeah, okay. All right, so that basically does our map functionality that puts us, you can go ahead and, if you press the Alt key, it's just like with an image, you can zoom in and zoom out on these guys. Functions, if you zoom in far enough, you'll actually see the street names and all that. Okay, so that's our start. That tells the map where we are. Since we don't, like I said, you don't have GPS enabled right now, we're telling it to zoom in on that spot. All right, so next thing we want to do is, if you go to your email or you already copied that URL out, so this guy, oops. If I go into Postman, so this is the handy utility that I like to use for practicing gets and puts and the like. All right, so if I send this off, this is calling a RESTful API that is, we're passing in a latitude, a longitude, and then this number is a company number. So this is a routed URL. So these are route parameters. Basically, when it goes up to the API, it interrogates for this number. This tells it what company. And then this is the latitude and longitude. And then the last number, the 6, is the number of stores that we want returned, or the maximum number of stores. So these should be 6 stores total. and then they have information associated with them. Distance from that coordinate that's passed in, the name, address, phone number, all that good stuff. All right, so what we're going to do is we're going to call out to this guy, get this data back, and then we're going to plot that on our map. Okay. So what we can do is create a function. Call that get list of stores. So the other night last week, we worked on loading up files, loading up JSON files. And when we did our drawings, we converted our drawing objects into JSON, which we stored in local storage. Tonight, what we're going to do is similar to that, only instead of pulling the data that we want out of a local storage file, we're going to pull it off the internet. We're going to get it from a REST API and load it up that way. So we'll create this function, get list of stores. First thing we need to do is create a variable for our URL. Post endpoint equals, and I'm going to copy this URL. Okay, so that's a string. Then from the string, we're going to do just like we did last week. We're going to create a NSURL object from that. And we're going to modify this URL, so I'm going to make this a var. Oops. And we're just going to pass this in with a string. And the string is the post EP. EP standing for endpoint. Okay, so what I'm going to do actually is we're going to make this dynamic. So I'm going to remove this stuff from it and just stop there with the 21. So that what we're going to do is, as we change location, or if the user changes location, we're going to modify this. We're going to append their lat and long on there, just like we, just as you saw when we posted it in the Postman. We're going to create that string off of the latitude and longitude. All right. So now NSURL has a couple of handy little features available to it that allow you to modify the URL by appending stuff to it. But the nice thing about the NSURL is that it has path functionality. So it knows the correct syntax and stuff for creating paths. And since this is a web URL, it works out really nicely. We don't have to use the file path stuff that we were using before. We can use the regular URL stuff. So we can say post URL will modify itself. Those post URL dot URL by appending path component. And the, actually, I think there's another method overload to this guy, because we want to tell it whether or not it's a directory. So essentially, this is a web URL that you're calling to an API, but in terms of the URL, it can be considered a directory. So when we put these slashes with the latitude, longitude, number of stores, all that stuff, that essentially can be considered directory structure, because it's going to look exactly the same. So the path component will be a string consisting of the latitude is directory is true. So that'll affix the latitude component. And we can do that again. Post URL equals post URL dot URL by appending path component. Do the same thing with the longitude. That's also a directory. Then the last thing we need to do, we could make this a variable, I guess, but the last thing we need to tack on there is the number of stores we want returned. So we can do that. So we can just say 6 for now. So what we can do to see this functionality happen right before our very eyes is in our view did load, we can call get list of stores, and then I'm going to remove the breakpoint from the centering of the map, and I'm going to put it down here and run it. Okay, so I can go ahead and debug this. So now you can see the formation of the URL. It's tacked on the 44.53, tacked on the 80, -89, and the 6. All right, so that's exactly what we want. So now we have a valid URL. I'm going to stop it. We can keep on our merry way. So now that we have a URL, we can create a web request. Call it cleverly request. NSURL request object. So the request object is, just as the name implies, it's an HTTP request. So with an HTTP request, you can set things like headers, you can set parameters, any body that you need. Like if you're doing a post request, it's still a request even though you're posting, but you can put data in the body of the post request. So for this, the constructor we want is our URL constructor. URL is our post URL. So that creates an NSURL request. A couple of the things that we need to generate in order to actually fire this guy off is we need to create a URL configuration. And they have a handy value to create a default configuration for that. And then we need to create a session, a URL session. Session is the object that manages the overall lifetime of your request. Handles things like timeouts, that kind of stuff. All right, so we can say let session equals NSURL session. It's with requests that I want. Nope, session configuration. That guy. And then we want default session configuration. That just gives us the vanilla wrapper stuff, which is all we need. And then we can create an actual session itself. Actually, let's call this config instead of session. That was mildly stupid of me. All right, we'll call that config. And then create a session. And this URL session is the guy. And this should take a configuration, which is one we just created. Boom. All right. There we go. So I didn't promise you guys that there would be less typing this week, because there isn't. There's a fair amount of typing that we have to do, but you don't have to worry about outlets crashing on you. That's the good part. All right. So that does all the wiring up that we need to do in order to actually create the request that we want. So the next thing we're going to do is we're going to create a task object. A task is basically it's kind of like a unit of work that we're going to tell the operating system to perform. And the nice thing about the task is that it will run basically asynchronously. So while the map is loading and doing stuff in the main UI thread, this task will be running in the background and pulling in stores. So we'll create that. It's going to be the sessions.data task with request. The request is our request object. But we're not done. So now in this data task, we can do what's called an inline completion handler. So the completion handler basically is defining what you want this task to do once it gets the data back. Only we're going to do it inline. We're going to do it right in line with the method body. So there's a predefined name called completion handler with a colon. So that basically is like a function pointer. So it's saying, okay, I'm about to define the function that I want to handle the completion of the data request. And then we do this, put an opening curly bracket, and then it automatically inserts the parenthesis at the end, which closes out this guy. So this is basically just a argument to our method. All right, yeah, we'll get around to that. All right. So it's complaining because we don't have the right number of arguments, which we don't yet. So down here, in this part, the completion handler for this type of request has 3 parameters that are predefined. Okay, data, response. So these are things that get passed back to us from the web request in a response, and an error. And then we type the keyword in, and then that starts off the actual code block that we're going to define. So basically what we're saying is normally you could just define a request, but we're telling it, okay, here's the completion handler. We want to define it right here, and this particular handler requires 3 parameters. One is the data that gets returned, second is the response object from the server, and the third is an error if there was any. So if we make a request, it's a bad request, it'll come back with like a 500 server error, or 503 or 404. Those are all invalid server responses, response codes. 404 is generally a resource not found. 403 is usually a permission error. 500 is an internal server error. 503 is an internal server error. If we get a 200 or a 201 response back, that means it was a successful request. The response was completed and returned something to us. So if it is an invalid call, usually the error will also get filled in with some sort of error information. So the error part is up to the server. So if the server is nice and it's coded in such a way that it will populate that, it'll return an error, then that'll have something in it. But it doesn't, even if you get like a 500 invalid response, the error is not necessarily filled in. So that can be nil. So you can't necessarily do a check to see if the error is nil, and then if it's nil, assume that it was a valid response. You have to actually usually check the response code. Okay. Is everyone kind of following this so far? All right. I know it's a little weird. It's a little convoluted. But we'll see it in action here in a minute. We can debug it and you can see the process. Assuming I didn't have another brain fart. Okay. Okay, so we're going to do this. We're going to use a guard. Guard basically is like another, we use the do, try, catch, now we're going to use a guard. It's another method of trapping errors. We'll call response data equals data. So we're going to set a temporary object equal to our data. All right, so this is some syntax that's unique to Swift 2. What it is the guardlet basically says, okay, if everything is worked out correctly, then we can go ahead and we can pull this data out and set it. We can assign it to something. If everything did not work out correctly, else do this. So this basically the guardlet statement handles the error condition first. It says, okay, if this works, fine, else, okay, we had a problem, then we have to handle the problem. So it kind of does the exception case first, which for some reason, that's actually the preferred method that Apple prescribes for doing this stuff now, is they want you to use this guard syntax. So, okay. In response. You can print that and then return. So I say, okay, if it didn't work right, we do the else case first, we handle that. We say, we just go ahead and print off, we had an error, return. And we can also do the same with the error code. So we're hoping that the error is nil, because that means we didn't get that set. The error is nil. Great, otherwise print it off so we can see what it is. There's different types of things you can print off from an error. Debug description gives you like the full stack trace. Usually you're not going to get that from a server request. But if there is an error, you'll probably at least have a description with the error. And again, you return it. So this is a little bit weird. So this, when you hit these returns here, these returns are actually not returning from this function up here. They're returning from this completion handler. So just so you're aware of that. Okay, so we got two guards. Finally, we can get down to the point where something went correctly. So this is we're going to code in our do, and then we can do a catch handler down here. That's error. So this error is going to be an error in the way we handle the data. Let's see, we can say catch error. This will be an NS error. And again, we can print the description off. All right, beautiful. Now, after all that, the actual meat of what we're trying to do. Okay, so remember that in the beginning we created this array of dictionary objects up here. I did that just kind of willy-nilly without really explaining it. But if you look at the structure of the JSON, this is a dictionary element, and this is a dictionary element, and this is a dictionary element. So a dictionary element is just an aggregated data type that has a key or a series of keys and values, keys and values. So a key-value pair repeated over and over. That's the way a dictionary in Objective-C works. And it models very closely with the way JSON works. With JSON, you have a string which defines the key, colon, and then value. Value does not have to be a string. In this case, I think they all are, including the distance. So I believe we did that by design so that if we have different types of clients, they don't have to know anything about the data types. They can just code them in all as strings and then do whatever conversions they need to do on the client. So that's, I think, why those are all string values. But anyway, that's the structure of it. And then up here at the highest level is an array bracket. So this is just an array of dictionary elements. So that's how I defined it here, was an array of dictionary elements. So if we are correct in the way we define this, we should be able to go ahead and deserialize the JSON that gets passed back into that dictionary. So we can say self.stores equals try. This is our try block. NSJSON serialization, and we did this the other night. And we need JSON object with data. That guy right there. The data is up here, response data. And I use response data because we are guaranteed that response data is valid because it passed our test up here. Response data. I'm missing something there. Should have knowledge of that guy. I'll try it. And then our options are just going to be an empty array as NS dictionary. All right. So just like we did with the file, only this we're doing with live data being returned from the internet. We're doing the JSON object with data, using our response data that we got sent back. And like I say, we use instead of using the actual data, Apple wants you to do this approach where you create a temporary variable and you set that equal to the data, and then you have a guard around it so that if the data is corrupt or something like that, you'll catch that, and then the error will be caught. So you can't be guaranteed necessarily that data is valid, but you should be able to be guaranteed that that's valid because you're doing this guard set. So essentially it's saying, okay, well, we know we have this guard around it, so we know that that's valid data. Okay. So with that said, I think we can go ahead and run this bad boy. I'm going to, I don't want to do that. I want to set a breakpoint. And then I'll set one in here too. And then we'll let the good times roll. There's our first breakpoint. Second breakpoint. Here we go. All right, so this is happening in the foreground. While this is happening, it's processing in the background. Hopefully. Or else we got an error. I didn't put a breakpoint in there. But nothing has been printed off yet, so it could possibly just be that slow. So I don't think it's that slow though. Alright, so I paused the debugger to see if I could determine where it's at. Yeah, I'm not seeing where we're at here. So you can see we have a few different threads running. Don't see anything to indicate where it might be at right at the moment. All right, so that's kind of weird. Didn't hit any of that stuff. I'll move these guys down. It didn't print anything off, so I don't think there was an error. But I'll put breakpoints in there just to see. I'll try running again. I'm going to single step this guy. You know what? I forgot one very important thing. Just occurred to me. In order for this to actually run, so it didn't do anything because it's just an idle thread. So this runs basically in its own thread. And unless you type this at the bottom of it, it doesn't actually run the thread. The .resume allows it to actually run. That would explain why nothing was happening. And continue. All right, so there we go. We're seeing something now. All right, so it looks like we passed the air conditions. And let's see if it will serialize it for us. It looks like it did. Response date is 2,195 bytes. Let's see if I can see what the stores are. If I go into the variable here, 6 values, which is what we expect. Each one has 18 key value pairs. And we're not going to see it because it's in its nasty little Objective-C format. But anyway, it looks like we successfully got stores back. So that's good. We aren't doing anything with them yet, but we got them. All right, so yay. All right, is everyone else able to run it and get affirmative results? If not, go ahead and give it a try. If you're just following along watching, that's fine too. So we haven't actually done anything with the map yet. So next thing we're going to do, we'll take a break, but next thing we're going to do is, since this runs in a background thread, the user interface really has no knowledge of it. So the way we give it knowledge of it, I mean, we could put like a timer in our view controller and say, okay, do we have data now? Okay, do we have data now? But a better way to do it is to use something that's called the Grand Central Dispatch, which is a notification system that Apple has. And what you can do is when an event occurs within the application, you can post a notification to Grand Central Dispatch, and then Grand Central Dispatch we create what's called an observer. And it's sitting there and it's like the observer is waiting for a certain event. And when you post that event, the observer says, oh, there's the event I've been waiting for, and then it does whatever it needs to do. So that's the next thing we'll do is once we're done with this, we will post a notification letting the view controller know, okay, we're done with the stores, here they are. And then the UI can actually do the job of loading up all the objects in the map. All right, so let's take a 10-minute break. Call it good for now. I'll stop the recording and make 2 recordings so we don't end up with a busted recording again.